friends, I am a cloud solutions architect who like to solve LeetCode problem, and today we are going to solve a very interesting LeetCode problem called Pascal's Triangle. Now, if we see some of the popular companies who have already asked this question, there are companies like Amazon, Bloomberg, Google, Apple, Microsoft, Goldman Sachs, TCS, Uber, Facebook, and Infosys. So that's why I am paying my utmost attention. I hope you also enjoy the video. So this is a LeetCode easy problem and also a very well-liked problem. Basically, we are given an integer array called number of rows and we need to return the first number of rows of a Pascal's triangle. Now, the biggest question in this problem is what the heck does this Pascal's triangle means? They have actually drawn a diagram over here and you can try to understand it using this. But I'm actually going to show you an animation that what a Pascal's triangle is. Okay, so now we are actually trying to create the Pascal's triangle, and for that I found a definition online. If we read through the definition, this is saying that, okay, in order to build the triangle or Pascal's triangle, basically we need to start with 1 at the top and then we need to continue placing numbers below it in a triangular pattern. Okay, that's a given fact. Second thing it says is that each number in the numbers is the combination of the two numbers above it added together. Let's try to understand this with an example. So over here we are trying to build a Pascal's triangle with 6 different rows, and I have drawn 6 rows over here. After marking their numbers, based on this definition, okay, first value has to be 1. So we are starting the first value as 1, right? Now what it says is that every single number is the number that is combination of two numbers directly above it. Now if we see this first box is only connected with one box at the top. So definitely the sum of this value is going to be that value by itself. So this is also going to be 1. Same with this value is also going to be 1 because both of them are only connected with one box above it. That is the key phrase, that one box above it. Same way, if we try to take a look at this box, this is also connected with just one box. So because of that, we are also again going to add 1 over here. But when we reach to this particular middle box, things become interesting. Because if we see this above part is actually connected with two different cells. So because it is connected with two different cells, we are actually going to do sum of these two. So 1 plus 1 is going to be 2 over here. And again, remember, this 1 plus 1 is coming by sum of these two values. Why? Because this particular cell is connected with both of them. Now, if we go back, okay, this one will always be 1 because there is only one element. Now again, this is also going to be 1 because it's only connected with just one element. But in this case, this particular element is again connected with two elements. So we are going to do the sum of it. So if we do sum of it, we get the value 3. Again, this is also connected with two elements. So sum is going to be 3. And this is only connected with one element. So sum is going to be 1. Same way we keep on repeating for the row number 5. So again, this is going to be 1. Now this is going to be sum of these two, which becomes 4. Now this particular element is going to be sum of these two elements, which is going to be 6. This element is going to be sum of these two, which is again going to be 4, and then again 1. Keep on repeating the same process. And this is how all the rows are being formed. And this is a Pascal's triangle. So in this case, we created a Pascal's triangle with 6 different rows, and we need to provide this as the answer. So as an input value, we are only given this element, that how many numbers of rows we need to create, and in the answer we need to return this one. And now the answer for these is needed to be written in a specific format so that our program can understand, and the format looks like a list of lists. So first we create an array list, and every single value represents all the values inside this particular row. So currently the first row only has one element, so we are only going to add one element over here. Now for the second row, it has 2 elements, so we are going to add 2 elements over here. Again, for the third row, it has 3 elements, so we are going to add all 3 elements over here, and so on and so forth. We keep on adding all the values, and in the end we return the answer. And this is the answer that is expected in this case, right? Now basically, I think this makes understanding much more clear that what a Pascal's triangle is. So now I have created a Pascal's triangle that is needed for like 7 rows, right? And for 7 rows, definitely I already showed you that how we are populating all the answers. That first this value is 1, this value is 1, 1, then again this value is 1, 2, 1. Okay, so this is the Pascal's triangle that we can create for 7 rows. But if you observe the answer, basically, first of all, we need to define that how the answer is being generated over here. The answer for any single cell is dependent on its like further value. Same goes for any single possible cell, that that cell is made up or comprised of the two cells that are exactly above it that it is being connected to. Now that is okay, that is one property. Second property is that in order to generate any single cell, how can we find its value? Well, we can simply find its values based on that if we have some way to store the value of the previous row. If we have that value, definitely we can able to generate the answer. And the thing is, because any single result is based on the results of its previously computed values, we are actually reusing the same value that we have already used, which means we are actually going to use the most beautiful concept inside the computer programming, which is dynamic programming in this case. Now for this dynamic programming, what we need a base case. So base case, what is going to be, that is already given in the definition of Pascal's triangle, that the first triangle is always going to be 1. So that is okay, that is a given fact, right? That this becomes our base case. Now based on this base case, I just showed you that we are able to generate any single triangle of any single length. In this case the length was 7, so we were able to quickly generate that. So the logic we are going to use in this case is that, okay, first we calculate the first value, we get the answer as 1, right? We store that answer. Now for the second column, okay, first what are the things we know about the second row? The thing we know about the second row is that there are going to be 2 elements, right? Now for this 2 elements, what is the thing we have? The thing we have is that we have one element that is present before that. Okay, so in this case, the first element is only possible to be connected with just one element. So since we have already saved that answer over here, we can simply leverage that, and same goes for the second element, that can only be connected with one element. So we can also store that answer over here. Okay, now we are at the third position. Now for the third position, what is the logic? So the first value is always going to be 1. So we can by default mark the first value to be 1, and also the last value will always be 1 as well. So we can also mark the last value to be 1 as well. Now for the middle values, what we are going to do is, okay, so currently if we see the index position of this middle value, the index position is going to be 1. Why? Because there are 3 elements. So in a typical array, the index position is going to be like 0, 1, 2. So this is like the first index position. Now we already know we are trying to populate this third value. And for the third row, first one value is 1. That is a given fact, right? Now for the second value, or the value located at index number 1, how can we calculate that? We can simply calculate that, okay, this is index number 1, right? So this index number 1 has to be connected with the previous value of index 0 and index 1. Then that you can see over here, that this was connected with like index value 0, and this was in an index number 1, and that is how this is connected. So all we will have to do is just do the sum of them, and that we can clearly found from the answer we have already stored over here, so which is 2, and again the next value we will get is 1. Now we need to create the fourth row. Okay, so for the fourth row, I'm not going to show you in the triangle, I'm just going to show you in the answer that how we will be able to generate that. So first value is 1, that is a given fact. We are trying to find 4 elements in this case. Now for the second element is located currently at like first index position, right? So because the index position is first, which means we will have to do sum of 0 and first index position, which is these 2 values. So in this case, the answer is going to be 3. Again, now for the second element, so this is like the third element inside this fourth row, and the second element in terms of like index value. So okay, the index value for this one that we are trying to find is 2, which means we will have to do sum of 1 plus 2. So okay, what is the value located at index number 1 in the previous value, which is this one, 2. Okay, and what is the value located at index number 2 in the previous value, which is 1. So 2 plus 1, so we get the answer as 3. And since we are only trying to populate 4 values, the fourth value has to be 1, because that is we already established that. So this is basically the simplest logic that we are going to use in order to populate our answer using dynamic programming. If you still don't understand the concept, I suggest you try to draw like any single Pascal's triangle. It's pretty easy to draw, and then you would be able to calculate the values. And basically using the dynamic programming, this problem can be solved really easily. If we see time and space complexity, in this case the time complexity is actually going to be big O of n square, where n is the number of rows that are given, and that is the best we can do. First of all, we are going to create a list of lists to store our answer. Now we are going to create our base case. So base case is that always the first value is going to be the 0, like the 1. And so what we are going to do is we are going to add a new entry over here. Now we have created our base case, right? Now as an input we are given the number of rows we need to perform. So what we are going to do is we are going to run a for loop, and inside this for loop we are going to run up until the we are going to start from row position number 1, and we are going to go up until the point where we reach to the number of rows that we need to reach to. Now for every single row we will have to create a new array list that we need to input. Also at the same time, for any single list we will actually have to require the previous list that we have calculated, right? So we are also going to create a new list to store the previous list, and we are going to name it as previous list. Now we have our value set up. Now first of all, for the new row that we are trying to add the entries, we are actually going to assign the value 1 into it. And now we are also going to run another loop. For this another loop, okay, let's just name the parameter integer j, and we are going to start it from position number 1. Why we are starting it from position number 1? Because we already filled out one value over here, and this is going to run until we reach to the value of this row that we are trying to reach. And now the core logic is actually quite simple. All we are going to do is for this current row, we are actually going to add the value, and we are going to add the value based on the result of the previous list that we got. And we are actually going to like get it using the j minus 1 value, and plus we are going to get it like the jth value. And basically this is the whole core of every single thing that we are trying to achieve. Now once we get out of this loop, remember the last value also needs to be 1. So again we are going to do that. In the end, all we need to do is just add this new row, that new list that we have created in our answer. So let's do that. And in the end, once we get out of the loop, basically our answer should have been populated, so we can simply return the answer. Now let's try to run this code. Seems like our solution is working as expected. Let's try to submit this code. And our code runs pretty efficiently, and it beats almost like 82% of the cases. Also in terms of memory consumption, it beats a lot of cases. Now I forgot to mention the space complexity for this one. The space complexity is actually going to be constant space. Why? Because anyways we are creating like a new answer list to store the answer, and we are only creating like couple of temporary lists over here. We are not doing anything extra, so that's why the space complexity is going to be constant space. And again, as always, I will be posting this solution in the comments, so you can check it out from there. Thank you.